Welcome, everybody. Nice to see some guests here as well from outside. So this is Karl Schoettle. Took me a while to learn how to pronounce his last name, and all of us were wrong, so I'm glad he corrected me. Of course, many of us are concerned about our climate, and Karl, I appreciate you being here with the Brooklin Climate Response Committee. Brooklyn, Maine, not Brooklyn, New York.
Right. Brooklyn with an I.
And his Grace is here, and Lars, which they're a part of the committee as well. So thank you for being here, and we appreciate you sharing with us today.
Thank you.
You're welcome.
So I'm Karl Schoettle, and I've been in printing and packaging for my entire life. And for many years, I was heavily involved with environmental affairs, with recycling, with pollution prevention, and finding alternatives to toxic substances through process improvement. When I first heard about global warming, I was very skeptical. Coming from a manufacturing background, I couldn't imagine that CO2 was going to cause us great harm. I began to investigate all aspects of science and human interaction, and I soon realized that this is a bigger problem than any of the environmental issues I had previously faced. For the past 15 years, I've been speaking publicly about what I have learned. The basis of my talks has changed. When I started speaking, the focus was on preventing global warming from affecting our way of life. But now we've entered a new era. This talk is being recorded on Zoom for the Brooklyn Climate Response Committee and will be available on the Town of Brooklyn website. We should have time for questions at the end. And if you're watching on Zoom, please post your questions in the chat. Anyone who is not currently on the Brooklyn Climate Committee email, please let Grace or Lars or myself know, or send us your email address, and we'll include you on our regular mailings. So jumping right in, climate expectations. Understand what's happening, what are the projections, what are available solutions that we know of, and how can you make a difference? So the greenhouse effect, what is it? Greenhouse gases, GHGs, they trap heat from solar radiation. They're a necessary part of our atmosphere. They are the thermostat for our climate. Without them, we'd be like the moon. Water vapor, H2O, water vapor accounts for half of the total greenhouse effect. Very often speakers say that water vapor is not really a greenhouse gas. Well, it is, but the difference is it's the only condensable greenhouse gas. What does that mean? Water vapor condenses. It creates fog, it creates clouds, it rains, it snows, it precipitates. So water vapor only stays in the atmosphere an average of about 7 days. That's why a lot of people overlook it and say it doesn't really affect our temperature. However, increasing temperature increases the amount of water vapor. Higher temperature, the air holds more water. Lower temperature, it holds less water. So increasing temperature increases water vapor concentration, which forms a positive feedback loop, which further increases temperature. Does that make sense to everyone? So looking back geologically, which we will in a second, the temperature actually increased before the CO2 concentration. Today, we've got it the other way around. It's an important difference. Increasing any greenhouse gas concentration increases the atmosphere's temperature, which in turn increases water vapor concentration. Water vapor is the amplifier of the greenhouse effect. It's not the cause, it's the amplifier, which is why, if we look back geologically at the cycles of warming and cooling, a lot of it can be explained by proximity to the surface of the sun. But that alone doesn't explain it. If you look at proximity to the surface of the sun and what that did to water vapor, that does explain the cycles. So increasing air temperature also increases carbon dioxide concentration. Good so far? Let's jump down a level. Fossil fuels are coal, oil, and natural gas. They are derived from previously living organic matter, organisms, also made of carbon, buried deep within the earth under high heat and pressure for millions of years. The non-condensable greenhouse gases, that means other than water vapor, are carbon dioxide, that's the biggest one, then methane, then nitrous oxide, then ozone, and lastly, the fluorinated gases, which are the refrigerants, the coolants. It's why you have a big deal to get rid of an air conditioner or something. So carbon dioxide concentration from natural causes was in balance with temperature prior to fossil fuel combustion. So I'll also show the cycle in here in a minute, but the image here is showing basically the way the carbon cycle works. So there are a lot of things that make carbon get absorbed into the earth, into the ocean, and likewise, there are a lot of things that send it into the air. I think we all know we breathe out carbon dioxide, and most vegetation breathes in carbon dioxide. So prior to fossil fuel combustion and anthropogenic, which means people-caused climate capture reduction. What does that mean? That means where we've cut down trees, where we've paved over vegetation, we're allowing less CO2 to be absorbed back into the earth. So carbon dioxide accounts for 80% of the effects of the non-condensable greenhouse gases. So essentially, it's 80% of the effects of something that we can control. CO2 stays in the atmosphere for roughly 100 years. This is why if we stopped emitting CO2 today, what's there today is going to be here for 100 years. So combustion of all organic matter releases carbon dioxide. So the other gases, methane, is emitted from not primarily fuel fossil combustion. It's emitted from leakage of oil and gas wells, from processing, distribution, decomposition, thawing permafrost, melting ancient ice, ruminant, that means cows and sheep, digestion, and fossil fuel combustion. Methane stays in the atmosphere for roughly 10 years. It absorbs solar radiation 30 times faster than CO2, and 87% of natural gas is methane. So the pie chart on the right shows you the influence of the different greenhouse gases, with the blue being the carbon dioxide, the red being the methane. Nitrous oxide is emitted from agriculture, land use, and thirdly, fossil fuel combustion. Nitrous oxide stays in the atmosphere for 120 years and absorbs solar radiation 300 times faster than CO2. So even though it's a small amount, it has a big effect. Ozone, which at Earth's atmosphere is better known when it's exposed to sunlight, is smog. It's produced by volatile organic compounds. It's basically anything that flashes up faster than water. So when you use cleaning compounds and you wipe it on the counter, it evaporates like that, that is VOC. So it's contributing to ozone, to smog. Same is true for nitrogen oxide. Fluorinated gases are neither naturally occurring, nor are they tied to the combustion of fossil fuels. So this chart is showing the relationship between carbon dioxide in green, temperature in red, and sea level in blue. As you can see, this is going back a little more than 400,000 years. So there's always been symmetry between these three elements. So ice core data, which even people on the peninsula have been involved in gathering ice core data. And this information is verified by NOAA, by NASA, and by EPA. So this is in blue is the carbon dioxide level. In red is temperature of our planet. So again, you can see they've always been in sync. This goes back 800,000 years. And in 800,000 years, CO2 concentration never exceeded 330 parts per million until 1975. Geologically, temperature increases have prompted increases in CO2. Now, CO2 concentration is driving temperature increase. CO2 concentration is now, this year, at 421 parts per million. The last time CO concentration was this high was 10 million years ago, and temperature was 30 Fahrenheit degrees higher than today. And sea level was more than 100 feet higher than today. Okay. What to expect? Increased meandering of the polar vortex in the jet stream will bring more weather anomalies. So the jet stream usually follows a nice wave going around the Earth. It's driven largely by polar vortex up above it, which is driving the waves of the jet stream. What's happened with warming is the jet stream and the polar vortex are no longer in a smooth curve. It's a wobbly curve. You can see this, the image on the left is a more normal jet stream. The image on the right is what warming atmosphere does to the jet stream. What does this mean? It means you can have all sorts of backups with weather. This accounts for why you could get 10 inches of rain in Blue Hill and it wouldn't rain in Brooklyn, or vice versa. It'll back up. This is why weather will stall, where their storms become much stronger, sit out in the warm ocean. And it's also why you hear about hurricanes that weren't even hurricanes, and they sit off the Carolina coast, and they just sit there and sit there and sit there, and they get bigger and bigger and bigger, and they come ashore a day later at a more than level 1 hurricane. This accounts for that. Extreme temperatures at unexpected latitudes is what we're seeing. People will say, well, it can't be global warming because it's freezing in Atlanta. We'll look closely because it's probably above freezing in the Arctic at the same time. So alternating floods and droughts will be more common. Quickly developing strong storms are more common, and larger and more numerous wildfires. Flooding in low elevations will become common due to sea level rise, wetter climate, and bigger storms. So remember, as the climate becomes wetter, it's holding more water. Or as it becomes warmer, it's holding more water. The International Panel on Climate Change, their limit of 1.5 degrees Celsius is no longer achievable. Expect temperatures to rise by at least 7 Fahrenheit degrees this century. Think about 7 degrees hotter all day long. That's going to happen this century. Earth's climate is changing too rapidly for many species to adapt or evolve. Expect excessive species extinction. I say excessive because a certain level of extension of species is natural, but what's happening now is not natural. Loss of biodiversity, more invasive species, loss of traditional food sources, loss of habitat, climate migration, and of course, geopolitical instability. What's happening in the oceans? Warming atmosphere is making the oceans warmer. As oceans warm, the volume increases, which raises sea level. Warming water expands. As sea ice melts, oceans absorb solar radiation faster than ice, raising sea level further. So sunlight hitting water, warms the climate much faster than sunlight that hits ice, where it's bouncing back. Expect more powerful and stronger storm surges, 4 to 6 feet higher by 2050. Expect sea level rise of 4 feet this century. I want to point out I was lucky enough, I guess, to be down at Center Harbor Shorefront on January 10th during the half an hour when the storm surge came in. And I will tell you, it was like a tidal wave the way it came in. It was quite scary. The water it wasn't a wave. The water coming in the Center Harbor was 6 to 8 feet higher than the water around it. And it blew the Brooklyn Boatyard dock, the Emery's dock, right off their stands. And what we have to expect, in fact, what we're hearing from NOAA is we should expect about 6 to 8 feet higher storm surges within the next 25 years if we have the same storms that we had in January. So when Arctic and Greenland ice melts, sea level will rise much faster. Most of the sea level projections you see here do not include melting of Antarctic and Greenland ice sheets. Warming ocean surface is destabilizing currents. The Gulf Stream is slowing, it's meandering more. The Atlantic meridional overturning circulation, which is the water that comes back under the surface. It's the bottom water that comes south. So typically cold water from the Arctic is going underneath the rising water on the surface. That is slowing down. Warming oceans hold less oxygen, contributing to more and larger marine dead zones. We already have a lot of places around the world where there are large parts of the ocean with nothing living. And this is going to expand as there's less oxygen. Oceans are becoming more acidic due to increasing absorption of atmospheric carbon dioxide. The rapid acidification is inhibiting the formation of calcium carbonate, which is the basic component of corals, shellfish, and vertebrae. So lobsters, clams, scallops, mussels, coral are all in trouble as CO2 concentration increases. Phytoplankton, which is the primary source of nutrition at the bottom of the ocean food chain, is in decline. So I haven't put this slide in traditionally, but I think it's gotten to be time to include this. Unless we urgently and drastically reduce greenhouse gas emissions and massively increase the capture of CO2, the following events are inevitable. Within a few hundred years, and probably sooner, because I emphasized that when I started giving these talks, I thought I was talking many centuries out before we'd see any of this happening. And now it's starting to happen. So within a few hundred years, and I'm going to say sooner than that, the current events can be expected. Most current human habitation will be submerged below sea level. Mean temperatures of both the atmosphere and the oceans will be too warm for most modern species to tolerate. The sooner we act, the better our chances are of mitigating the worst of these conditions. Everybody upset now? So why are we responding so slowly? Let's look at the human side of this. Too many people do not grasp the urgency or the severity of what is happening. Misinformation, particularly on social media, causes doubts and inaction. Big oil has had a strategy now for about 30 or 40 years of denying it, then delaying it, or delaying what they say is happening, distracting people, and now they say it's too late. So I would emphasize here that in my study of this topic, I have looked at so many things on social media, and I've questioned all the ones that counter what I've learned elsewhere. So I've screened this pretty well. Public policy is out of touch with technology and climate realities. $7 trillion of global subsidies for fossil fuels is driving climate change. Too much of the US economy is based upon cheap, plentiful fossil fuel energy. Current cost of ethane makes virgin plastics too cheap for recycled plastics to compete. Increasing impervious surfaces, urban sprawl, blocks biosequestration. I'll get into biosequestration in a second. Fear of jeopardizing a strong economy is a big element. A lot of people think the economy is going very well right now. You know, my investments I need them for retirement. People are afraid that moving away from a fossil fuel economy to a clean energy economy may upset that apple cart. Human nature. Political, religious, and social beliefs outweigh facts. Social pressure and peer influence. Convenience, consumerism, luxury preferences. These are all driving climate. Inability to adequately weigh the long-term consequences of our action due to undetermined timeline for climate change.
The energy problem. Some people say the climate problem is an energy problem. Demand for energy is increasing at a faster rate than the increase of renewable energy capacity. Renewable energy is basically usable electricity produced without combustion or burning of organic matter or carbon. In addition to needing more capacity for renewable energy, we also need more storage, and we need smarter and more robust grids. Data centers, artificial intelligence, the cloud, and electronic vehicles are all creating huge new demand for energy. The images here are of Amazon Web Services and Google's data centers, which draw an incredible amount of energy. Global population growth, of course, is demanding more energy and higher standards of living. Everyone wants what we have. Natural gas is a short-term subsidized energy solution with long-term hidden costs. Some states, such as Pennsylvania, are building tremendous infrastructure for natural gas. They're also providing incentives for their customers to switch to natural gas as their primary source of energy. This makes short-term financial sense for their customers because natural gas is so cheap in these states. A lack of coordination between legislators, public utility commissions, and energy utilities is a major stumbling block to our growth in renewable energy capacity. Fear of nuclear energy is another big problem. Not in my backyard. Most people are afraid of nuclear energy because they don't understand it. Some people actually think that electricity generated by a nuclear power plant is somehow radioactive. The only accident at a nuclear power plant in the United States was at 3 Mile Island, and the safety valves worked, the reactor was shut down, and no one was injured. Energy solutions. Most electricity in this country follows a top-down architecture, which is not conducive to sharing resources at a local level. Distributed energy resources, microgrids, smart grids, virtual power plants are all very good ways of sharing energy so it doesn't all have to come from the big power plants. Generating, storing, and sharing electricity at a regional level makes great sense. The good news about nuclear power is small modular reactors are in the final stages of development and should be ready for deployment within the next few years. Heat pumps are the most efficient way of heating your home. Heat pump hot water heaters are extremely efficient and they are a great source of dehumidification. Most people putting heat pump hot water heaters in their basements can eliminate having a dehumidifier. Natural gas furnaces are still the cheapest, but that can't last much longer. Solar, wind, hydroelectric, and geothermal will all be a part of the solutions for the future.
Often not mentioned in climate talks, biosequestration. By sequestration, that's pulling greenhouse gases out of the air. Photosynthesis, basically photosynthesis where all plants, trees, all the way down to grass, are pulling CO2 out of the atmosphere, putting it into the ground. Vegetation captures CO2 as the soil contains more carbon. So you should plant more trees, leave no soil bare. Unfortunately, I'll mention this again, but things like the Farm Bill in the United States do not call for cover crops. And when farmers pull their crops and leave the ground bare, the bare ground is not absorbing any CO2, which it used to do. So don't till the soil. It's something that goes back to pre-industrial times when people thought you had to till very deeply in the soil in order to get good planting, to put seeds in. And we found that that is not the case. You can plant seeds in very shallow areas. The problem with deep tilling of soil is you are killing the microbes in the soil. And the microbes in the soil are the things that want to absorb that carbon dioxide back in. So biodiverse soil is more resilient to weather conditions. Healthy soil brings larger yields with more nutritious crops. Controlled grazing makes soil healthier. Eliminate synthetic pesticides and herbicides, support pollinators, restore and protect coastal wetlands and saltwater marshes. Organic farming emits 40% less nitrous oxide than conventional farming. This is the other side of climate change. Geoengineering. I'm not going to go through all these today, but this is a pretty good list of what is being worked on right now to sequester greenhouse gases. I think half of these can't work. I think a lot of these have bigger negative consequences than they have benefits. But I'm just pointing out here, this is a growing list. It seems like every couple of months I can add something to this list.
Public policy impact. The United States is the only major industrialized nation with no tax or cost recovery on carbon dioxide emissions. The U.S. economy must eliminate dependence on fossil fuel prices that do not account for any environmental or human costs. Private investment needs financial incentives to switch to renewable energy and away from fossil fuel energy. Citizens Climate Lobby supports a bill that would tax carbon at its source and pay equivalent dividends to all U.S. residents. Previous bills that supported taxing carbon have not moved forward, primarily because the funds would go to direct funding of renewable energy technologies. And those technologies have not had universal support. Politically, if all U.S. residents receive a dividend, that's something that most people in Congress are happy to push. The EPA and state agencies will set limits on carbon dioxide emissions. Federal procurement will set primary and secondary greenhouse gas emission limits. And the Federal Energy Regulatory Commission will enact regional transportation planning rules. The Farm Bill, while it has a lot of political support, it's misunderstood in that it blocks natural carbon dioxide sequestration. 90% of all U.S. farms are using conventional farming. MethaneSat is a satellite that is capturing images of oil and gas wells that are leaking methane. Your financial impact. Make your investments part of the solution. If you own stock in a publicly traded company, make sure to vote your proxies. Or if you have a financial consultant, make sure they are voting proxies in line with your desires. Most public companies publish their climate voting policy guidelines. Make sure either you know about these or your financial advisor. The EPA tracks Scope 1, 2, and 3 greenhouse gas emissions reporting. That basically tells the emissions, number 1, by the company directly, number 2, indirect emissions, and number 3, emissions by their suppliers. All 3 must be tracked. Check the merits of ESG, environmental, social, and government scores. These are publicly available. They're not as important as the EPA scope scores, but they do count. Look for participation in industry-specific decarbonization agreements. Pay attention to which financial institutions are supporting the big greenhouse gas emitters. Most banks and insurance companies are underestimating their risk for climate factors. Casualty insurance is underpriced right across the country based upon even modest estimates of climate projections. Consider legal remedies. Consider the big cover-ups. Compare what's happening to the climate to what happened in big tobacco. Watch out for greenwashing. Terms like sustainability, recyclable, compostable, clean, carbon neutral, carbon credits, carbon offsets, energy transition credits. These terms alone have very little substance. Recyclable under what conditions? Compostable under what conditions? What does somebody mean by clean? Carbon neutral by a certain date. Does that mean they're actually reducing their own emissions? Or are they buying carbon credits and not actually changing their own emissions? The process of changing from fossil fuels to renewable will be expensive, but an economy based on renewable energy will be far more stable with better, safer jobs and lower total energy costs.
Behavior, buy electricity only from renewable sources, buy organic foods for the climate and for your health. Choose electric over hybrid transportation, buy only what you need, avoid fast fashions. Don't look at that catalog if you don't need something. Avoid single-use plastics, reduce microplastic pollution, recycle to reduce demand for resources, energy, and disposal. Use only LED lighting. I emphasize this because a lot of people have old incandescent light bulbs, and they say, as soon as that burns out, I'm going to put an LED in there. Wrong. Get rid of it now. It will be well worth the savings to get rid of the incandescent bulb and put LED in. It's a no-brainer. Get rid of incandescent. And even if you have CFL, those curly cube things, get rid of those, put in LED. Replace gasoline with powered machines. I have an electric chainsaw, I have an electric leaf blower, I have, what else? All kinds of stuff, and it works very well. I'm pushing some of the contractors around here to go electric in their lawn mowing machines. And they say, well, the batteries don't last enough. And I say, fine, you put a battery bank on your trailer or in your truck with a bunch of batteries. And every time a battery runs out, you just switch batteries. And at night, you plug the thing in, you plug in the trailer. So there is a good solution here. It's just trying to get people
to buy a new, they would have to buy an electric.
Right. Yep. And frankly, in our area, there have been enough people that support this. They've offered to buy the machines for the contractors, but they're resisting it because they're not sure about changing batteries. Manage your land organically, plant trees wherever you can, don't pave where you don't have to pave. Try and eliminate impervious, non-penetrable surfaces wherever you can. Buy locally grown foods, eat meat. I don't say don't eat meat, but I'm saying eat meat from pasture-raised, grass-fed animals, and compost. You can make a difference. Understand your carbon footprint. And if you're not sure about that, the EPA has a very nice calculator. Talk to your family and friends about what's happening. Write and talk to your legislators and influential associates. Participate in the regulatory process. Great thing in this country. You can communicate directly with your legislators. Make sure they know what's happening. I would emphasize that I have and I continue to try to speak to legislators because I find even ones who are strong advocates for clean energy, they don't understand fully what's happening. And if you don't understand what's happening, you're not going to give adequate measure. You're not going to try hard enough to change. Vote in every election you can. Look for candidates who understand the climate issue. And lastly, I emphasize focus on solutions. Thank you. Any questions? I know I threw too much out there. Couple of things I would emphasize. This is, hopefully we got a good enough recording. This will be posted on the Town of Brooklyn website with all these slides. And apart from that, I'll make sure the slides themselves are available as a separate download off the website. So thank you all for coming.
So Karl, what's the I'm going to call my legislator. What am I going to say?
I'm going to say, do you or does the Environmental and Energy Committee in your district or in the state understand climate change? Because if they say, well, I'm not sure if they do. And I've spoken to people on the Energy Environmental Committee who have said, I understand enough that I have to support this. To which I say, if you don't understand it truly, you're not going to be as committed as you need to be. So I push the education aspects of this. And I truly believe that if people understand everything that or even most of what I'm presenting here, they will do what they need to do. They will realize that this is not a matter of compromise.
So a second question would be, is the message different depending on where you live, either geographically or organically? That is to say, you live in the city, you live in the country, you live in the countryside, you live in the North Pole, you live in the equator. Your
local message is very different. Brooklyn, Maine, Blue Hill, Maine is very different from Portland, Maine, but the state message is the same. The federal message is the same. It's the total issue.
Package.
It's the total package, because what's happening in Kansas is part of the picture as much as what's happening in Maine. It's kind of like when we used to say, well, we're downstream, we're downwind from the coal-fired power plants, so we have acid rain in Maine, which other people don't have as much of. This is a big umbrella. And people sometimes to China, and they say, well, how can we save things with China doing all the polluting they can? China is doing much more than we are. China has so many more electric vehicles than we have. China doesn't allow most people to have clothes dryers because it takes too much energy. So China is doing much more than we are. They just have a much, much bigger population. So we can't point the finger at other countries. We, the United States, are by far the big emitters per person, per state, per anything. You know, on a per basis, the United States is the big emitter. Yes.
As the people here know, I'm a doctor, and I've always maintained that we are part of the problem because we're increasing the human population. And every animal species on Earth will control its population, either through increased death rate or a decreased birth rate. We as humans are the only species that has a choice. But if we don't choose a decreased birth rate, we will get an increased death rate as we are already getting. And I heard just an interesting comment the other day. In the United States, we are doing something about it, and our birth rate is going down. And according to this article, that is causing a serious problem because now there won't be enough workers to support the older people. So we need to start producing more kids, so we'll have more workers to take care of the old people. Where's the answer?
The answer is whether you like or don't like immigration. Immigration is a great thing for this country. I mean, without it, what you described, we wouldn't have enough people. You know, tell me Parker Ridge doesn't need more good employees. You do. Everybody does. All the boatyards, everybody's looking for good employees. And most of the immigrants that come into this country want to work. You know, it's usually the first generation people in expect to work. They want to work. So population growth is a huge part of this problem. No? Well, I don't want to keep anyone from lunch. I'm happy to answer questions at any time, either directly or through the Brooklyn Climate Response Committee. And again, if you're interested in hearing from the committee does send out regular reports. If you live in Brooklyn, the committee is also doing home visits, which are essentially informal home audits, showing people how they can be more energy efficient and save money. Grace is a huge part of that because she keeps in touch with Efficiency Maine and the state regulations and where there are great incentives for people to put in heat pumps and do other things at home. Thank you all.
Thank you.
Thank you for being here.
Thank you.